Hello and welcome back to another episode of Effective JaRu, the series where we have a look at effective Java and try to port things over to idiomatic Rust. Item 12, consider implementing comparable. So if you have some sort of class that has a natural ordering, you should implement it because then you can basically sort stuff and use all kinds of algorithms that rely on sortable things. So that's so far so good. I think there's a description of what what comparison should be able to do, and it kind of follows the rules of the equals comparison in a way. So it needs to be reflective, transitive. Where's the other thing here? How's that called? Yeah, symmetric. All these things. Awesome. So I think the code that we see here, it upgrades the phone number. Accordingly, it also shows you how to do this with the case insensitive string here. It's quite interesting. I think two things are interesting here because if you want to do this, you have to implement, implement this comparable T, and because this is a generic interface, you will not have to do any casting, for instance. So you work with your type already. This is special in Java basically because everything can otherwise boil down to just the base object that you have. And something, in the implementation here, by the way, it returns an int, right? So it's kind of the C star thing where it's -1, 0, or 1. Which has its difficulties because people can then start write that, like area code minus PN area code, and then use that as a difference. You could say, wow, it's great, but actually that will only work if the domain of these numbers are matching. And, you could get into trouble if there are integer values that are too far away from each other, because then you have overflows and these just make your stuff fail. So probably you don't want to do this optimization unless you are totally sure that you got it all figured out. Okay, so here's item 12. I think I would be best off to copy item 11 into item 12. Yeah, I think I can also go there. Oops, the lock is something I shouldn't have to manipulate, but this thing I should, because there's lots of code to write, I guess. So first of all, the phone number got a new compare to method here, which is nicely documented. And I think we want to have this for our phone number as well. So item 12 lib. And in Rust, you do this, I think, by implementing std cmp I don't know, no, comparable something. Let's see, I think it's the comp module, but I rarely implement this. And there is the ord, exactly. Ordering, right? Which is very nice. It's called ordering, and this ordering is defined so that comp just returns an ordering enum, which is less, equal, or greater, which is awesome. It's verbose. You don't have to remember what -1 is supposed to mean. And then you can implement it. Ord, I'm not sure if you can auto-implement ord. I don't think so. I don't think this works. So here we go. That should totally fail. If that works, then I'm very happy. It could possibly work. No, ord doesn't work. I mean, that would have been new to me, so you have to implement it yourself. Awesome. So we just implement comp take borrows from self to another, all immutable, and return an ordering. And we can basically implement it the way it's done here. I mean, we can try to do a rusty and thus safe version of it, so no special stuff happening here. Import for phone number, and we have a comp method that takes a self and an other. How do they call it? Other? Not that it would matter, but I think I call it right hand side, which is another phone number. And not to forget, it returns a comp ordering, but I think I'm fine with importing that as well. Like this. And we are there. Now, let's start with the area code. And we basically just go in order of most significant to least significant. So the area code is the most significant, and we want to drop out in the moment this is not equal, right? So yeah, we have to keep the value. Let's keep the value or the comparison value C and say, well, self area code compared to the RS area code. And now if C isn't ordering equal, then return C, right? And if at the end everything is good, return ordering equal. I just put this here so that this would already compile, just to see we are kind of on the right track here. Oh, partial ordering. Oh, now I get it. It wants to tell me this all the time. Partial ordering. Yeah. So ORD C, I've seen this here. ORD requires equality and partial ordering. So how does partial ordering work? Larger than, greater than, partial comparison. And you get an optional ordering. So I guess, I don't know if one auto implements the other, possibly, but how would this be done best? Yeah, so partial ordering, that's implemented for floats, for instance, right? This is the only reason that exists. Yeah, so basically we need to implement just this partial comparison. So let's try to start with partial ordering then. Partial ord. And that returns an optional ordering then. And apparently I missed something here. It's called partial comp, of course. Makes sense? Not the same. So yeah, in this case, we return some C. I'm not sure if I like that. Because we will... Yeah, partial ordering probably should be implemented in terms of ordering here, because this stuff here, I don't like it. So let's do it that way. So we have partial ord and ord. And apparently partial ord is not auto implemented for us, but we will just do this ourselves because we only have to implement fm partial comp, which takes a self. Damn it, my typing today is extra bad, which really means a lot. And we have an optional ordering. And it should be enough to say, well, self comp RHS, and we provide it with a sum, right? So that should be a good implementation. Now this should build for us. Okay, it wants a borrow of that, not a copy. So here we go. Cool, so that works so far. Now we can basically just go ahead and do the same thing. Can we reassign this? I don't think so, but we can just do it like that. Self prefix comp RHS prefix. Nothing can go wrong here, right? If C doesn't equal ordering equal, then return C, and we're good. And last but not least, this can now go away. We just return the final result of the ordering of self line number compared to RHS line number. Obviously, we should not forget to pass in a borrow. And that's the implementation here. It looks very similar, even though it's exactly very, very clear what's going on. Something special is the differentiation between partial ordering and ordering to basically fit the floating point numbers in there correctly. So the algorithms in Rust, they can be safer because that's a notion. They can protect themselves against special stuff like floats, or they can explicitly support them, right? If you work on partial ordered items, then you can deal with this, and then you deal with this particular interface, which has optional orderings, right? So that is that. Let's see if that compiles. It would, if I would have gotten the case right. And yeah, there's a little test program that runs that tries to use this phone number. I guess we could now try to make this a real library, put this public, the implementations are there, that's all good. So now I would need a main, st source main.rs, give it a main here, and now we can say, well, extern crate item 12, please. Then we use item 12 phone number just to get it into this namespace. And yeah, I guess we can create our own little function here. Do we have random number generators in the standard library? Or is this a crate? Generate floating point number. Oh. Rand, bool, rand, U16 rand, really? Where is this rand coming from? Why? Because I think there is a random, this is in an external crate, even though here it claims to be implemented, and I wonder what that is supposed to tell me. That's weird. Probably something that wants to be fixed. Maybe it is already fixed. Nightly. Maybe it's already gone here. Rand something. Random. Ah, here it seems to be kind of gone, huh? It's more gone than it was before. Awesome. So that would be it. I think we need a crate here for the random number stuff. Maybe we could also improve, just get different instances by incrementing a counter or something, which should be fine to some extent. Random phone number. It would be interesting how it deals with the ranges. So it gets a range within a certain certain limits here. Yeah, let's have it. Random. New random. And we get a phone number out of this. I just put it in here because it's really our private thing. We could also put it outside. It doesn't. It all doesn't matter. But now we would need the random crate here. Extern crate random or rand. I think it's called rand. And then we can also adjust the item 12 cargo toml file. Yeah, interesting. Now actually only the main, you know what? Now only main would require random, right? So we could provide a random phone number for in the library, which kind of makes no sense. And I also would refrain from putting it here because it's just for testing and just to be able to execute this and print something. I use main here. Usually this would be a test case, right? You know what? Let's do something here. Let's have a state. So that's a mod u16. That's a state where everything starts from, and then we basically just increment this state while generating the phone number here, and hope that this works. You know, it's not truly random, but it's something, and it will generate something that we can stuff into the tree set, and maybe put in an assertion or two, because now we are comparable, and I think tree set needs that. Our Rust version of tree set would need that as well. So let's skip the random stuff. Extern create item 12, it doesn't like it for some reason. Okay, so area code is S. How do I increment it in place now? I don't think I can. Maybe I don't have to. Maybe just say s plus 0, then prefix s plus 1, and the line number as s plus 2. Oops. And then we could just keep this for a moment, return it in the end, and then increment this in place. That would make it easier to use. And then we say state plus equals 2 or 3 to get to space it out a little, or maybe plus 1, that would also be sufficient. So there we go. And now let's see where we can stuff it in. It's std collections. We have a hash set. I'm not sure what else we have here. And what kind of restrictions there are on the members of these things. Hash sets. Yeah, we have used hash set before. B-tree map. I think this is what we want. Interested in what the smallest and largest key value pair is. And to find the largest and smallest if you want to keep things ordered. Yeah, so that's a B-tree map. Good, we use this one. B-tree map, here we go. And now we have letmod m, which is a B-tree map. New, actually, let's reframe from all the type stuff that can be inferred anyway. And now, yeah, for something in 0 to what? To 10. Do new random, so we say m insert, I guess, new random, and the state letmod s be 0. We might want to say that it's u16, but actually I think as we use it here, it can be inferred. So that would be enough even, I think. So let's provide it with the state here, and that should already be something that can compile. Cargo build bin. No! Why is there no item 12? I am in item 12, cargo Tomo of item 12. Oh, this is why. Okay. So now insert, this function takes 2. Oh, interesting. So yeah, we could just map it to something else then. How do we get min and maximum values then with that thing? So it has keys and values. This is not exactly what I want. Values is empty, range mud. But of course we can make it work. It also doesn't impose. Okay, here it imposes ordering. This is kind of what we need. Where key is orderable. Okay, so I guess we just put in this one as key and a unit as value, and now this should work better. No, we can't. Oh yeah, we want to say phone number new checked, right? And then this will read a bit better even. Yeah. Maybe I just do it like this. Looks good. And sure, we get a result here that we just want to unwrap. The cool thing is, if you unwrap something, we know that this can possibly fail. Right now we don't do any error handling or so. Now at the end, it prints the map, which should now be sorted, right? Thing is, we add it in a sorted fashion anyway. So maybe we start with a high value. Oh, damn it. We can start at 999 possibly and then go negative. Which of course makes this thing here a bit more difficult. We really want to have random numbers here to show that it sorts correctly. I guess. Yeah. Maybe. Yeah, maybe we can do it differently. Maybe we can give it a state that is not altered. And then just do a reverse iteration or something like this. And if we do it like that, then we can kind of skip this entire utility, huh? Well, why not? Why not keep it that way? So anyway, now we can use this, which even looks better, and we say, well, we go in reverse. Should give us a reverse iterator over it. We just drop in the copy here. And now the ordering that we have would be natural. So even though we put in numbers starting at 10, it would end up going being ordered correctly. So let's see what happens here. If we print that, we do some serious pretty printing and print M. Let's see. I have no idea if that will work and how it will look. Yeah. Oh. Really? We don't need the state either. So let's run it. And yeah, as you can see, it's properly sorted, even though we put in different ones, right? We put in area code starting at 9 and so on. This can be proven by maybe even printing this iterator here, or this index, which starts at 9 indeed. Yeah, so that is that. Kind of our cheap way to do it, right? Why use random number stuff if you can use something deterministic that still proves it? Yeah, I like that. I also like the code. That's neat. And yeah, I think we have something else just for the fun of it, which kind of makes me want to put this one into the testing portion, or yeah, let's put it into the testing portion then of our crate. Well, we can have multiple binaries. Did you know that? So let's have multiple binaries. Yeah, so this is random phone numbers of phone ord. Let's have it. Item 12 cargo Tomo. So we have one bin that whose path is source main, and the name shall be phone, and we have another bin whose path is source arc sort, because that's what it will do. What's the time saying? 25 minutes. And the name is arc sort. So this is actually the source, which is arc sort is, right? All right. So let's have an arc sort RS here. Actually, not from this one, but from this one. Arc sort RS. No, it ignored that as usual. And here we go again with another main. And what this should do is basically show how the standard type string is already sortable. So it adds it to a set because the whole idea is to prune it as well, right? And it should be sorted. So let's see if the tree set here is actually requiring ordering as well. Where is the hash set actually? I think hash set only requires a hashable item, huh? That's interesting. I thought... here it is. So hash and equality, yes, so that's not good enough. So I think a B-tree map is what we would need, or is a B-tree set the same? Look, actually the B-tree set is what we wanted in the first place. It needs ordering, but orders the keys, and yeah. Let's fix it real quick. B-tree set. And then we can insert this without the tuple here. This should still work. Bin and phone. Cool. That looks a bit cleaner now. And is what we wanted. So now the arcsort thing. Same thing here, huh? We use std collections B-tree set. Let map be a B-tree set. And yeah, at the end we print it, obviously. We do some serious pretty printing though. And yeah, I don't know why it doesn't like it. Now it does. Huh, interesting. Let's just keep going, or maybe read what it has to say. Oh yeah, type annotations required, sure. So we should just keep going here. And oh no, wait, actually in order to get it from the arguments use std-env. So I think what we can do is collect right into a B-tree set. We could do this by saying that this should be a B-tree set of an inferred type, and then I should be able to just say env args collect and do let type inference do the rest of the thing. Look at that. Arc sort. So that is that. Let's have foo bar 1 1 2 3 9 2. Oops. Yeah, of course we might want to just put it like that. Oh, yeah, just a second. No, actually, I will keep going and just finish this. And yeah, as you can see, this totally works. It cuts out duplicates and sorts it alphabetically. Awesome. And yeah, which code do you prefer? Huh. This code. Because it's just to the point. I love it. I love it already. I didn't expect that at all, but that kind of shows you what type inference is capable of and how beautiful things can be that way. So collect is just functionality of the iterator trait, which happens to be implemented for the iterator that is returned here. And so we can collect it into something that we define on the left side. We could also define it here, but I find it usually easier to tell what I want here. Also note the underscore, which basically says that type inference is supposed to determine the type of the thing, which is going to be a string in that case. Very nice. Thanks for watching and have a great day.